For my individual design project, I decided to focus on the foldable and collapsible footstool. We split up the project into 5 parts, 5 checkpoints. The first checkpoint focused on the constraints and limitations. This was also part of the brainstorming process, and I focused on what a footstool should and should not do. A footstool should be made of a sturdy material, and it should hold enough weight to support any type of person that will be on a footstool. The foldable and collapsible footstool also is expected to expand and collapse. It would also be great if it was portable. Checkpoint 2 was the brainstorming phase. In this phase, I brainstormed for materials and possibilities in order to make the foldable and collapsible footstool work as best that it could. Some of the main points that I ended up using were foldable, hinged, with pegs, aluminum, an electronic raising platform, piston activated, 2 steps, 3 steps, pipe frame, textured step surface, handrail, and a larger top step than the other bottom steps. Moving on to checkpoint 3. Checkpoint 3 focused on the analysis of the brainstorming stage. I chose to separate my ideas into material steps and solutions, with the useful objects from the brainstorming stage in each category. Material included aluminum, wood, plastic, and pipe frame. Steps included 3 steps, 2 steps, textured steps, hanging steps, and the size of steps. Solutions included adjusting pegs, hinged, foldable, and handrail. Solutions were things that would make the footstool foldable or collapsible. Checkpoint 3 also included a couple different solutions. You had to create 4 solutions. So solution 1 was made of aluminum, had pipe frame, had 2 steps, and it was hinged. And the ideas that were associated with the solution 1, it would fold, but it probably wouldn't adjust. It would probably be cheap to produce, but it might already be a product. As you can see, there's also a column for the pros and cons over here. Folding is a pro, not adjusting would be a con, and so on. Solution 2 was a hydraulic press that would adjust electronically, but it would need a battery or plug. It would also probably only be 2 steps, 1 base and 1 adjusting step. Now, solution 2 would probably be very expensive, and it would need power. It would also not be portable, but it would potentially be the tallest of the solutions. Solutions 3 and 4. Solution 3 had adjustable pegs, an adjustable handrail, 3 steps, a pipe frame, and it was hinged. Solution 3 might not support a lot of weight, but it would be inexpensive, adjustable, and foldable, which would also make it portable. And solution 4 was telescoping with aluminum, hinges, and pegs to hold the telescoping pieces in place. Solution 4 probably wouldn't support a lot of weight. It would probably be very inexpensive to produce, but it might already exist. Involved creating designs. So this is solution 2. I picked, I believe, solutions 2 and 3 to make a high-cost design and a low-cost design. Now, as you can see here, the high-cost design is the piston-activated footstool that includes telescoping tubes with pistons down the middle, and this would be activated by pressurized air from the air tanks down here. And so the air tanks would release air, it would push the pistons up, making the footstool go up, probably around 3 feet tall at the max. And then wasn't quite sure how you'd get the air to go back into the tank, so we have a chain with a crank that would end up pulling down the top step and compressing the air back into the tanks, because if you compress the air, hypothetically, they would have no other place to go but back into the tanks. The low-cost design was solution 3, and this included a lot of adjustable pegs, spring-loaded pegs, and telescoping sections. It has 2 steps and an adjustable handrail, all of which are telescoping, so that it would end up only being about 1 foot by 1 foot when folded and unadjusted. It's got hinges on the bottom so that the steps can fold downwards, and then the steps, when unfolding, will go into small holes in the step below it. Checkpoint 5 was the last checkpoint, and this included an analysis of the materials that would be needed, as well as the price point, and a hypothetical schedule for design and building. So the high-cost design needed quite a few materials, including sheet metal, airtight pipes, air canisters, chains, chain hoists, pipe, gaskets, bolts, and texture for the top step. And I looked on McMaster-Carr for most of these prices, and you can see all the prices listed here, and the total price that I came up with was $691.25, which is a little outrageous for a footstool. Now, the low-cost design is still outrageous for a footstool, but it would be very portable and foldable and much cheaper than solution to the high-cost design. The materials that would be needed would be the same telescoping pipes, sheet metal, hinges, spring-loaded pegs, texture for the top steps, and bolts and accessories for attachment. You've got prices listed, and the total price comes to around $291, which is much cheaper, but still very expensive for a footstool. Checkpoint 5 also included a hypothetical schedule. Now, I only have one chart because they were very similar in the design process for both footstools, and I don't think it would take a different amount of time to design either model. So you'd start with brainstorming, give you 1 day, and reviewing existing products would also be around that same time. You would have to analyze ideas, create multiple rough designs, pros and cons to find 2 designs, design high-cost model or low-cost model depending on which design you chose, and then ordering parts and building the prototype probably would take the longest. And then you've got testing and redesigning, and then you'd have to order more parts, and then you'd build another prototype, and it would continue like that until eventually the final product was released. Thank you. This was my individual design project, the foldable and collapsible footstool.